Hello and welcome to a new outdoor knife. For this knife build I use parts of the Damascus steel that I made in the last video. The small bar is made of pumpkin steel and the larger one is the 128 layers Damascus steel that I made the last time. It's the first time for me that I start and finish a knife build in one video. In the beginning I make the individual pieces for the knife, then forge weld them together, do the heat treatment, edge it and make a handle and it's done. But first I show you how I make a herringbone pattern. I forge a Damascus steel billet that is double the length that I need for the pattern. I forge the bar round and leave the ends as a square. Then I heat it, clamp one half in the vise and turn the other half clockwise. Then I do the other side counterclockwise. After that I clean one part of the surface where I want to weld and cut it almost in half. The last steps are folding, forge welding and then the pattern is finished. And that is the design for the knife. Herringbone pattern, pumpkin steel and then O2 steel as a cutting edge. Since the pumpkin Damascus steel billet has been made in the last video already, I can immediately start to twist it. This bar I only twist in one direction. I hammer the bar flat because it's gonna be sandwiched between the O2 cutting edge and the herringbone pattern. It is time to forge the O2 tool steel into the right dimensions. The starting billet was almost 2 by 2 centimeters, so you can see how effective and strong my new forging press is. And now it has reached the final thickness. That means I can start to draw out the 128 layer Damascus steel that is going to be used for the herringbone pattern. At first I forge it square, make it round, mark the middle and it's time to twist it. The first half clockwise and then I turn it around and the other half is going to be counterclockwise. After the twisting, I straighten it and I make all parts straight so that I can forge weld them together. Once they are straight, I clean the surfaces where I want to weld them. At first, I start by finishing the herringbone pattern because I need it done before I can forge weld all the pieces of the blade together. As usual, I'm going to use borax as a flux for my forge welding operations and I also clean the parts in between. I set the initial welds with fast and light hammer blows. Once I'm sure that the weld is good, I start to use harder hammer blows, although I need to make sure that the pattern is not disturbed too much. The herringbone pattern has to be long enough so that I can use it for a knife with a 14 cm blade. Making it straight again. And it matches perfectly with the pumpgun steel Damascus. Cleaning the welding surface again. I assemble the three parts of the knife blade and then tack weld it as a preparation for the forge welding. The pumpgun steel in the middle, the herringbone pattern on top and the O2 as a cutting edge. I start the forge welding with light and fast hammer blows again. This is the part of the knife where the tang will be, and here the forge welds need also to be very secure. It is time to offset the tang for the knife. And I use a guillotine tool for it, and these dies make sure that they cut in a straight line, as you can see here. I draw out the tang. I want the Damascus pattern to follow the form of the knife, and therefore I cut the tip at an angle and then slowly and with light blows bend the tip over. I need to be very careful because there's lots of shearing forces that are very hard on the forge welds, and I need to make sure that they stick together. It is finally done, and now I forge the knife into its rough shape. I start to forge in the bevels because then I don't need to grind away so much material. Checking with a ruler if it's long enough, and 14 centimeters is exactly what I was aiming for. That means I can start to forge the handguard. I use wrought iron from an old wagon wheel, and I guess that it's more than 150 years old. When I'm finished with the forging, I let all the parts cool down slowly in the forge. That makes the material softer and easier to grind. I grind the knife into its rough shape before I resort to hand sanding. I want the knife to taper from the handle towards the tip, and therefore I shift the pressure points further forward. The next step is marking the grind lines, as they help me to be consistent. I use my self-made file guide to have a nice straight corner where the handguard meets the blade. At this stage, the finest belt has a grit 80 before I start to hand sand, and there I use a grit 120 to get rid of all the perpendicular grinding marks, because it reduces the risk of cracks when hardening the blade. After the hand sanding and before I start with the heat treatment, I punch in my maker's mark. I initiate the heat treatment with a normalizing cycle, making sure that the structure in the steel is fine and even. I heat the knife blade to 820 degrees centigrade and preheat the quenching oil, because a warm oil cools faster. The moment of truth has come. If you listen closely, you can hear nothing, which is very good, because it didn't crack. Testing with a file if the steel hardened, the file isn't biting, so it's good. I anneal the knife in the oven. While the blade is baking, I continue with the handguard. At first I drill a hole and then I make a slit. Grinding the tang to its final shape. Adjusting the hole in the handguard to fit the knife tang. I want to make sure that there's no space and no crack between the blade and the handguard. Final shaping of the handguard before it's off into the edge. In the meantime, I continue grinding and sanding the blade. I hand sand to grit 400. I etch the blade in a very weak ferric chloride solution, and that gives it a very intriguing pattern. Afterwards I prepare the parts for the handle. starting with a birch bark that I cut into 3.5 by 3.5 centimeter pieces. I start the construction of the handle by gluing together a few pieces of birch bark. I drill in holes and make them to small slits. Preparing the end cap made of wrought iron as well. It is time to glue the handguard onto the blade. I want to make sure that there's no gap between the handguard and the knife, and also wipe away all the excess epoxy. Then I glue together the main part of the handle. I use an epoxy with an open time of 30 minutes, because that gives me plenty of time to assemble all the parts. When that is done, I fix the parts and let them cure overnight. The next day I take it apart, mark where I want to grind, and then start to shape the handle. Grinding and shaping a handle is very easy. You just have to grind away everything that is not part of it. And of course, that takes time and quite some practice. As usual, working at the grinder is followed by hand sanding. You can see that I mounted the end cap already. That is just to give it the final shape, and then I put it away again, etch it and re-glue it to the handle. After the epoxy is cured, I finally pin in the small pin, making sure that the handle cannot come apart again. The final adjustments with a sandpaper of 400 grit. I use linseed oil to seal the birch bark. And it also looks good. The knife is finally done, and I think it looks amazing. It turned out exactly the way I wanted it to be, with the herringbone pattern, the pumpkin steel, and then the O2 tool steel as a cutting edge. This knife is going to be a present for an old friend, and I wish you all the best and lots of fun with your scouting knife. If you like what I do, please support me by liking the video and also subscribe to my channel for any new videos. Thank you very much. Thank you for watching the video. I had a lot of fun and I'm looking forward to the next one. I wish you all the best. Bye bye.